For the second part, we'll do some examples. It's not going to take too long. I prepared 2 examples. We'll see if you want to do both of them or not. Let's have a look. So we have this robot. Let's try to understand it, because we use these drawings as well for the exam, so it's good if you understand what they represent. Unfortunately, we cannot 3D print robots for the exam, maybe. But yeah, so here we have the reference frame X, Y, Z. We have a revolute joint, basically rotates around the vertical axis Z. So it's something that does like this. Okay. Then there is some link with length L1. Then there is a joint with the axis that comes out of the screen. So when you see these diagonals, usually something coming out of the screen, like this X is coming there, this Q2 is there. Q3, so it's basically Q1, Q2 is like this, and Q3 is this rotation. So it's an axis of rotation to the right. And Q4 is the same orientation as Q2, so it's like this. All right. And the end effector is here. Let's say I draw a frame here, X, Y, Z. So this is Y, this is X, this is Z. So this is my end effector. Right, so I want to calculate the pose of the end effector with respect to the reference frame. What are the steps? What do I have to do? Let me draw this as well while you're thinking. This is basically and then so I have to use some color. X, Y, Z. Z is up. Y, X. Great. What's the first step? Identify what are the links and the joints. As I say, I try to describe this is a joint rotating like this, joint rotating like this, joint rotating like this, joint rotating like this, and the links, link, 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 link. Good. Second step. What do we have to do?
Identify reference frames.
Identify what?
Reference frames.
The reference frames. So put some reference frames, right, at each link at the joint. So I would have another one here, but this one would be attached to this link, so it would rotate with the joint. I forgot to write down the joint Q1, Q2, Q3, Q4. All right, so this would be the first on the first link. Here I would have on the second link rotating like this, right? Here it would be on the fourth link rotating like this around the green axis. I will put more as we progress, or I can actually draw. So this would be like this and like this. So 0, 1, 2, 3, 4, and 5, as I have it there, it would be like this. Okay, great. And next step?
To render transformation translation from each.
All right, so let's write them here. R from 0 to 1. This is 0. I'll say 0, 1, 2, 3, 4, 5. Translation on Z, or? Yeah. All right, they're actually down here, so there is no translation. Let's say they're at the same level.
Just rotation around Z.
Rotation on Z, right? I said that this frame is attached to this link which rotates, right? So rotation around Z by how much? Q1. Great. 0 to 1, just a rotation. 1 to 2. Sorry, translation Z or? Yeah. TZ by this length L1. All right. And rotation around X by Q2 multiplied from the right or from the left? So I have this one and I translate here and then I rotate around this X. Let's put it in a rotated way. So I translate and then rotate around this X. It's from the left or the right? If you don't get it correct, it's not your fault because I confused you. So it's from the right, right? Because it's relative. Q2. Right? 8 is from the right. Here, because I rotate around this one, I have to multiply from the right. Okay? Good. From 2 to 3. Now, I did this and this stayed here. You can imagine that when Q2 rotates, this whole thing moves. We're gonna see it better hopefully next week where I will have a 3D printed robot here. I'm still trying to finish it, but yeah, the idea is that everything that is after this joint, it moves with this joint, right? The same thing from here to here. When this one rotates, all of these rotate, the whole robot rotates.
Translation on Y.
Translation on Y. Come on. By L2. And then rotation on Y. From the left or from the right?
Right.
I might rotate around this Y or this Y? Huh? What do you say? They're the same one, right? You can imagine this is not this short, it extends to infinity, right? So they're the same ones. So then around this one or that one?
Either one.
Yes. The answer is yes. This one or that one? Yes. We said at some point that when I deal with matrix, this is not true in general, but sometimes it is. And you will see that when I have a rotation and a translation around the same axis, I can swap them around. Okay, or if I have, let's say, rotation on Y and then another rotation on Y, rotation on Y1 and rotation on Y2, I can swap them around because it's actually around the same axis. So in this case, it doesn't matter if I multiply from the left or the right because I'm translating around the Y axis. So then that axis doesn't change. right? It's the same before or after. So then it doesn't matter if I rotate around the old y or the new y. Unless the y is misbehaving and it's not staying where it should be, right? But to keep things symmetric, let's multiply from the right. Be careful with this. Better to assume that this is never the same, but you will see that in some cases it's actually the same thing if I have rotation and translation along the same axis. All right, so I have translation on y and rotation on y. Then from here to here, from 3 to 4, from 3 to 4, I have another translation of y by L3. Yeah, there I have it as one translation, and I'll explain you why. Okay. And rotation on x by q4 from the left or the right? From the right. X by q4. And R4, 5, it's just a translation on y, right? Ty by L4 or L3. Now there I put L2 for the whole distance from this axis there. Why? When I try to calculate the forward kinematics, what will I do? Sorry, R05, it will be R01, 1, 2, R2, 3, R3, 4, R4, 5. Okay, multiply everything together. Let's take just these two. What will I have? I will have Ty, Ry, Ty by L2, rotation on y by q3, and translation on y by L3. Correct? And rotation on x, okay. So just this part. This part. Okay, it's translation y, translation y, rotation x. Right? Because I have this translation y, translation y, I said when I have transformations along the same axis, I can change the order. Right? So I can rewrite this as, let's say, in any way I want. Let's say translation y L2, translation y L3, rotation y Q3, rotation x Q4. Right, so I have these two translations, one next to each other, which I translate on y by L2 and then by L3, so I can also combine it as one translation of what? L2 plus L3. Right, imagine I translate on this direction by L2 and then I translate by L3. It's the same as saying, okay, I translate by L3, L2 plus L3, right? So that's why I take that as one translation, which I can call how I like. I call it L2. Okay, this is just extra insight. So when I want to calculate the pose of the end effect with respect to the reference frame, I take all these matrices, I multiply them together, and I have in the end again a 4x4 matrix, a function of q1, q2, q3, q4 that tells me how the end effector will be orientated and positioned with respect to the reference frame. Okay, that's what forward kinematics is about. Any questions? No. Right. One more example in the same way. Here the difference is that I have a prismatic joint as well. So basically until here we have the same robot, I think, yes. Let's see how we deal with prismatic joints as well. Nothing fancy, but good to see. So I have this link, and here I typically draw prismatic joints like this, as if they can slide on this little stick. Okay, and I have another joint here that rotates like this. So let's say this is Q4, and Q3, now it's this distance, so it's not an angle. This distance is variable because this joint translates along this link. All right? R0 to R1, I erased it, but it's the same one. So rotation around Z. R1 to R2 is translation on Z by L1, rotation on X by Q2. Good. What is, let's say I put my next frame on top of this moving part. So what's the transformation from 2 to 3? Translation on Y by how much? By Q3, it's variable. Right, and I have another frame attached here. This one rotates like this. So this is 3 to 4. Translation of Y by L2. By Q4. Again on Y. Now again the order doesn't matter. Okay, and then let's say I have the same frame down here. Translation on Z by minus L3. All right? I multiply all of them together. R01 from the right, R12 from the right, R23. So I calculate the overall transformation R05. Don't have the equation here, but details. Any questions? So in the lab you will have to calculate the forward kinematics of the little robot that is on the table. So we start using that robot. And now you know how to do it. You will see what are the joints, you will measure the distances, you will put the frames, we have the little frames, and calculate the forward kinematics of that robot. Right. As I said at the beginning, this is the first part of forward kinematics. Next week we will see a more structured way of placing the frames and doing the calculations for links that can have different shapes. Here we saw simple examples where everything was perfectly aligned and we had simple transformations from one link to the other. But that's not always the case. So we'll see a more structured way of defining the forward kinematics using what we call the Denavit-Hartenberg convention. So that's when we will complete forward kinematics. Any other questions?